I'm Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is media access control, random access. Here, the outcomes of a random access in a media access control. Here is media access control. It is nothing but a unique address of a device. The manufacturers now uniquely can be given to the other device. This is a MAC, that is a media access other control. That means random access. Random access the protocols. So randomly can access the protocols in a media access other control. The outcome of this is efficient in a low traffic and collision management and scalability. So these three are the outcome of the media access control in a random access. You see, efficient in a low traffic. Efficiency in a low traffic means now random access the protocols, different other protocols which efficiently communication in a low traffic network. Here, these random access of the protocol now, low traffic. Whenever the traffic between the two devices is a very less other traffic, in a less traffic, these other protocols, random access of the protocols now efficiently communicated between the all other devices by allowing the devices to transmitting the data. So whenever they are ready, whenever the devices are ready, data will be efficiently can transmit without loss. Now data will be either transmit. So this is a loss can be reduced. Efficiency in low traffic means losses, data loss can be reduced. This is one outcome. And the next outcome is a collision management. Collision management means now reducing the collisions with help of the random access protocol. By using the random access protocol now, we can reduce the other collisions, which is providing the mechanism. That mechanism is a back-off timer mechanism, such as back-off timer mechanism. By back-off timer other mechanism now, in the traffic, in the device the communication, multiple device communication, multi-environment now, if any collisions are occur, so that other collisions can be resolve the collisions and reducing the collisions with the collision management the technique now, which ensures very fair access, very safe access to the shared media, whatever the medias, whatever the networking medias are involved. So that shared networking medias now data can be sent very safe with this the collision the management by resolving these are the collisions over the network. Safely we can transmit the other data. Scalability. Scalable, that means now this random access of the protocols, whatever the protocols we are discussing, that is a random access of the protocols in a medium access control, which are scalable over a large area networks. Large area networks now. So these protocols are scalable and also these are all the measurable and scalable. Why? Because now which is allowing the number of bulk amount of the devices. Bulk amount of the devices by allowing the bulk amount of the other devices now, the communication can be established between the bulk amount of the other devices without a centralized coordinator. With help of this protocol here, the centralized without necessary of the centralized coordinator, now the communication can be established which is scalable and measurable. That's communication. Here, this is the outcomes. And media access the control. Generally, the definition we can say it as a random access. These are the protocols in a media access control, which is refers to the method. This is one method. random access in medium access control is a method. By using this method, by using this random access in medium access control, the method now managing the devices over the network. Whatever the devices are the communicating over the network now, via this the communication media can be managed without predetermined schedule. Without the predetermined schedule now, the device the communications can be effectively managed with help of the random access protocol in a medium access control the technique. So in this the technique now, what will do, the devices, whatever the devices are connected over this network, so the devices are transmitting the data safe when they are ready. That means it will be resolving these collisions or any data losses. So that will be resolved. So whenever not two devices are try to transmitting the same data, so it will be handled through the process that attempts to resolving or avoiding all these other collisions. This is about the MAC, random access in a MAC. Here, some of the key characteristics of the random access protocol in a medium access control are no central control. So first the key component is a no central control. No central control means now the devices make their own decisions. With help of this the protocol now, own decisions, they will take the own decisions and transmitting the data from one device to the other device. This is a no central control. There is no central system control to the devices. Whatever the devices are working. So over the random access the protocol in a medium access control. Collisions handling. So next the key characteristics means now large amount of data. If the large amount of data is allowed over the network, the collisions, whatever the different other types of these the collisions now, all the collisions can be handled. That means now if two devices are transmitted simultaneously, generally the collision can be occurred here whenever the two devices are simultaneously transmitting the data. Generally in this other case, in this other situation now, collisions will be occurred. Here is both must be retransmit after a random backup period. It will be retransmitted after a random backup period. And also the efficiency. Efficiency is another key characteristics of a random access protocol in a MAC. Here is the efficiency means now, so random access can be the inefficient under the heavy traffic. Suppose the large networks now, we are establishing the communication over the large network now, so it is a inefficient. So why? Because now in a large networks the heavy traffic will be arise. The chance of why? Because the collisions, the chance of the collision will be the increased. So in this large network, that's why here if the collisions are occurred, the data will be losses. The damages now, which is losses to the transmitting the devices, whatever the devices are transmitting, the data will be losses. And here in these are the cases now, the devices now which is leading to the retransmissions and delays. The data need to be retransmitted and so delaying the data. And multi-access the protocol, multiple access the protocols here. So random access protocol in medium access control. So it is one of the multi-access protocol. Random access protocol is one of the medium access of the protocol. Multi-access of the protocol generally, which is categorized into three types. One is a random access protocol, controlled access protocols, and channelization of the protocols. These three categories now it will be categorized. Now we are discussing about the random access protocols. Here these random access the protocols are again now different types of these the protocols. Now it is categorized as Aloha protocol, CSMA protocol, CSMA CD protocol, CSMA CA protocol. Let us discuss one by one. This is a random access protocol. Now different methods of a random access of the protocols for broadcasting the frames on a channel. So these are all the Aloha, CSMA, CSMA CD, CSMA CA. So let us discuss one by one. First, Aloha random access of the protocol. So what is a Aloha random access of the protocol? Aloha protocol now generally it is designed for wireless other communication. Any mobile communications or any wireless communications, wireless local area network, no, it will be designed, the Aloha protocols can be designed for that one. But now it is whatever the wireless and the for whatever wireless communications now for that purpose designed. So it is also can be used in a shared medium to transmit the data. Shared medias. Shareable. That means now the resource shared media means now the resources can be shareable to the multiple devices. So in this shareable other devices also shareable shared media also now this Aloha random access protocol can be utilized. By using this Aloha, this is the method. So any station can transmitting the data across the network simultaneously. Simultaneously here without other collisions. This Aloha random access of the protocol now without other collisions, collision free data transmissions can be done across the network. Here the device, one device to another device without other collisions now data effectively can be other transmitted. When the data frame set is available for other transmission. Here the data here generally the data can be transmitted using this the Aloha the protocol in the form of the frames, data frames. And Aloha, if you take the Aloha protocol now for data transmission from one device to another device now, which is following some rules. The rules are any station can transmit the data to a channel at any time. So this is the any time to any channel, whatever the channels are available over the transmission media. So the data can be transmitted to the any station, to any other channel, depends upon the availability over the network. Second rule means it does not require any carrier sensing. Here in Aloha protocol now, not require the sensing. Generally, CSMA, if you take the CSMA protocol in a CSMA protocol, so the signal sensing is required. You want to transmit the data, so in mobile communication, so the signal sensing is required. So whenever the signal is available, then only we can transmit the data. That means voice over the communication. The best example is a mobile communication, voice over the communication. In voice over the communication, what we'll do now, carrier sensings can be done. That means now the network, which is checking the network. If the network is available, then sending the data. That is the best. The example is a mobile communication. And third one is the collisions and data frames. Collisions and data frames may be lost during the transmission. During this the data transmissions now, any collisions or data frames may be lost during the transmissions of data through the multiple stations. Now, so it may be the collisions, any other frames may be lost. It will be happened with Aloha the protocol. So acknowledgement of the frame will be existed in a Aloha protocol. So here is if the data is transmitted with help of this Aloha protocol now, the sender which is receiving the acknowledgement from the receiver, whatever the data is transferred, for that the particular data like as a successfully transmitted now, which is getting the acknowledgement. That means it is getting the acknowledgement means there is no collisions as detected here. Without the collision free, the data is transmitted. If the source device receives the acknowledgement, collision free data is transmitted. It requires the retransmissions of the data after some random amount of the time. Suppose if any collisions are occur, after some time delay now, which is required to retransmitting the data. Whatever the data previously transferred, same data need to transfer. Here is generally Aloha protocol. Take the Aloha protocol for data communication. Generally, it is categorized into two types of the protocols. One is a pure Aloha protocol. Second one is a slotted Aloha protocol. We take the differences between the, observe the differences between the pure Aloha protocol and the slotted Aloha protocol. Pure, in terms of this pure Aloha protocol, time synchronization. So pure Aloha protocol means no time synchronization is required for this one. Without other time synchronization, pure Aloha protocol now, which will be transferred. So which is required the time synchronization. That means at a time. Time synchronization means at a time now data can be transmitted and receiving the acknowledgement. Here is the transmission. In terms of the, in aspect of the transmissions, data can be sent at any time. So time, there is no limit, there is no other time. So in this time we have to send the data, there is no time. Any time now the data transmissions can be done from one device to the another. That means source device to the destination device. Here is in a slotted Aloha now, data can only be sent at a beginning of the predefined time slots. Within these the time slots, the data we have to send. But in a pure Aloha, there is no time slot. So any time now, so whatever the available time from the available other time, any time we can transmitting the data in a with the help of the pure Aloha. But slotted Aloha, the allotted slots only. So we have to transmit the other data. That is a slotted Aloha, and this is a pure Aloha. And in terms of the throughput efficiency. Throughput means here per second how much data we are transferring from one device to another device. So this is the meaning of the throughput. And maximum efficiency, in terms of the efficiency throughput is a, in a pure Aloha now, if you take the pure Aloha, 18.4% the efficiency can be achieved. But in a slotted Aloha now, slot time based slot based now we are going to transferring the data. So in a slotted Aloha, maximum efficiency now which is required, that is a 36.8% efficiency can be achieved. So in a slotted Aloha. Collision portability. So collisions generally higher collision portability will be exist in a pure Aloha. Why? Because now since the transmission overlap freely, so that's why the collision rate, the probability is very high, and the collision probability in a slotted Aloha is a very low collision probability. Why? Because now these slotted Alohas, so which is within a slot, within a time period now, the data can be transmitting. That's why the collision the probability is very low. Only begin at the time slot at the boundaries. Delay, in terms of the delay, higher average delay. Average, in terms of the average, now if you take the average, the delay is a very high. Why? Because due to more the frequent other collisions, number of other collisions are exist in a pure Aloha. Number of other collisions means no, anytime we are sending the data, there is no time slot. So that's why many devices simultaneously sending the data. That's why the number of other collisions will be increased. Average, in terms of average now, if you take the slotted Aloha, in terms of average, very lower delay. Data delay, the delay is the data transmission delay is a very low due to the reduced collisions. That means now in a slotted Aloha, maximum 95% of the cases now the collisions will be reduced. That's why delay will be the very low comparing with the pure Aloha. Complexity means now simple to the very simple to implementing the, for implementation now, these are the pure Aloha implementation is very simple comparing with the slotted Aloha. Slotted Aloha, why? Because now is more complicated. Now in terms of these slots, why? Because now it is more complicated means now the data can be transmitted in terms of the other slots. That's why the complexity is a very high complexity is slightly the more very ambiguous. Data transmission rate is very ambiguous. And here media access control. That means a random access in a media access control here CSMA. CSMA means here carrier sense multiple access. Carrier sensing. Here that means now the carriers sensing mobile. The best example for this in this mobile other communication. Now networks. Now which is sensing the networks. If the networks are identified by identifying this sensing by identifying the networks now, then only the data signals will be transmitted. The carrier the signal sensing can be the data can be transmitted. It is a carrier sense multiple access based on a media access of the protocol. Here is the MAC of the protocol. Now you can say it as a carrier sense CSMA is a carrier sense multiple other accesses. Based on the sensing now, the data transparency can be done to sense the traffic or the communication media on a channel, whether the device is a busy or device is a idle now. By sensing we can determine. So with help of the CSMA. Here is before the transmitting this other data. It means that if the channel is idle now, the station can sending the data to the channels. That means based on the channel availability, the data transmissions can be done from one station to the other stations. Otherwise, now it must wait until the channels become idle. Whenever the channels are idle, then only the carrier signals. Now the signals can be sent to the particular identified as the channel, whatever the channels are idle. Hence now by communicating like this now, which is reducing the channels of the collisions of over the transmission media. The collisions can be reduced by channel availability. Now if it is available, if you send the data, the collisions now as early as much as the collisions can be, we can reduce. Here medium these access controls, these carrier sensing access the methods now. Different types of these the access, the comparison here. So one persistent CSMA and a non-persistent CSMA and a P persistent CSMA, Q persistent CSMA. Different the persistency CSMA accessing methods is there. The accessing methods are, if you take the mechanism in a one persistent CSMA, generally this one persistent CSMA now, which is continuously sensing the channels, whatever the channels are idle, whatever the channels are available now, which is continuously now sensing the channels, and transmitted whenever the channels are available, whenever the channels are free, immediately transmitted. Immediately the transmission. When the channel is idle, immediately it will be transmitted the data and establish the connection for communications. That means here non-persistent CSMA, if we take here, senses the channels, and if they are busy, non-persistent means if they are busy, waits for a random time before sensing again. Here is now in a mobile communication, the best example mobile communication, if the second of the person, the third party of the person now, if he is already communicating with another persons now, here the channel is not available now, waiting for connecting that other channel. Again now trying, again trying. That means now trying for getting the sensing. That means senses the channels. Trying to non-persistency CSMA. So if the channels are busy, always now which is trying to getting the channel. So up to that now it is waiting for some particular random time before the sensing again. And P persistency is CSMA. P persistency, that means here senses the channels. P persistency is senses the channels and transmitting with the probability based on the other probability. Channel available probability when the channel is available or not, when the channel is idle or not. What is the probability of the idleness of a channel? Based on the idleness of a channel, the probability, now the signals can be sent. Based on that now, data and signals can be transmitted, which is differs with the probability of the the persistency the CSMA, which is entirely different. Q persistency CSMA. Q persistency CSMA now here is also sensing the channels. All persistency CSMAs are sensing for channels. If it is channels are available now, establish the other connections and communication can be established. That means here data loss, collision loss, other communication no. So it is trying to resolving the other collisions and data loss. And also this is a Q persistency and the CSMA if we take here transmitted with a fixed the probability. That means Q after a random at the back of now fixed the probability, it will be considered the fixed the probability. By considering the fixed probability, data will be transmitted. Here is the collision probabilities. In terms of this the collision probability in a one persistency, the collision probability is a very high. Why? Because as a multiple stations may transmitting the immediately. Here is main multiple the stations. Multiple stations are station or device or workstations, all are the same. Multiple workstations are transmitting the same time. So that's why when the channels becomes idle here now, which is requesting to the for idleness of this other channel, if the channel is available here, immediately the multiple stations or workstations will be transmitted. That's why the collision probability is very high in a one persistency CSMA. Non-persistency CSMA means now so very low. As why? Because as a randomly weight, reducing the simultaneous attempts to transmitting now, which is waiting for at particular time. If it is why? Because now why it is waiting means now the channel in a non-persistency maximum of the cases the channels are not available. The channel is not available here. It is not connected to the other device here. That's why randomly it is waiting. That's why that is the collision is waiting time is more time comparing the one persistency, P persistency, Q persistency. That's why the collisions are very low comparing all persistencies. Here P persistency CSMA. P persistency CSMA actually which is depends upon the value of the P. That is a tunable. Now value of the persistency, that the probability value here, based on this the probability value, these are the collision the depends upon this the probability. So it will be the collisions will be arised depends upon that the probability. Q persistency, the collision of the probability, so depends on the Q and so back off for the timings. Here is now this is a differentiations in terms of this the collision probability and efficiency. Efficiency is a less efficient due to the high collision rate in a high other traffics, and also non-persistency CSMA also better efficiency in a light other traffic, but may cause the delays in a very high traffic, heavy traffics. That means the P persistency more efficient in a moderate traffic or optimal with appropriate to the probability. That means depends upon the probability, the efficiency can be determined here. In Q persistency, efficient, the transmitting the rate is very efficient in both the light and heavy traffic. So if it is the traffic is a light traffic or heavy traffic now, so the efficiency will be more within the adequate there is a Q persistency. Throughput means here actually per second how much data is the transmitting. It is nothing but a throughput. So in a one persistent CSMA, moderate in a low traffic, drops in a high traffic. Here it's a moderate. Throughput is a moderate. That means per second data transmission rate will be the moderate. Non-persistency also the moderate to good in a low traffic and may degrading in a heavy traffic. Here is the throughput will be data transmission rate will be the degraded. But the traffic is a very low now. The data transmission rate is a moderate. So that is a throughput. Data transmission rate per second is a throughput. And P persistency means now can achieve the optimal throughput with the proper the tuning of the EP. So this is of the P persistency CSMA and Q persistency CSMA. Q persistency CSMA means balances the throughput well across varying the traffic levels. The traffic levels. So this is a it will be the data transmission rate based on this the traffic now it will be balanced and delay low. So in a one persistency very low and non-persistency delay is a moderate. And P persistency also moderate and tunable depending upon the probability rate. And Q persistency is adaptive here the low delay due to the dynamic backoff and Q tuning. Here this is a delay, data transmission rate delay. So applications generally rarely used due to the high collision rate. Theoretically it is a interest. The applications now non-persistency is suitable for the light traffic networks. Purpose now this it is a non-persistent CSMA is a suitable, and also any random applications. Also now it is a suitable here. And P persistency also now used in the scenario which is requiring the balancing delay and the throughput and balancing will be balanced. So for balancing purpose now we can use this P persistency CSMA. And Q persistency CSMA is very effective in a dynamic traffic environment. That depends upon the load. Availability now it is a very and media access control. So in this the media access control here CSMA now different graphical presentation now one persistency here is now the continuously sensing the continuously. Here the sensing continuously now senses and the transmitted by sensing if the channels are available along with the time now. So if it is available it will be connected and transmitting the data. In a one persistency, so if you take this one persistency and non-persistency, so always busy waiting for sensing, waiting for the signaling. If it is the signal is available, then will be allocated. That means now it is waiting after some time also it is trying to wait here. Waiting always generally it is always busy for connecting the other channels along with the other time sensing and transmitting. If it is a senses occurred, it will be transmitted. Otherwise waiting from starting onwards. So that is a non-persistency. P persistency. In P persistency, so first starting the continuously sensing and it is a busy. The probability depends upon this. The probability now. The probability does not allow the time slot. And here the outcome transmission the time slot here depends upon this. The probability. The signals can be transmitted. The value of the probability. If the probability is very high, transmitting the signals to that particular other device. And this CSMA CD. CSMA CD is nothing but the carrier sense multiple access with a collision detection. So it is a medium access control protocol used in a wide network. That means now CSMA CD wide network transmission control protocol generally we are using. Always now sensing and detecting the other collisions. If is there any collisions now, so the data transmissions can be at the stop. Here such as the best example is the Ethernet. Ethernet means now generally it works by always sensing the channels. It is working based on the sensing the channel before transmitting the data. If there is if sensing, if checking and if the CPUs now if the devices are available, if the devices are free, if the devices are idle, now data transmissions can be done to the particular other channel. If the channel is clear, the device will be transmitted. That means now whatever the communicating device, it's the free here depends upon the channel availability. Now the data transmissions can be at the time. That is the best example is a mobile communication. And so if a collision is detected during this other transmission in CSMA CD collision detection. CD means collision detection. These the devices now stop sending the data. If there is no collisions are detected here, the devices now which is sending the data. Otherwise now the devices now which is stop sending the data. and waiting for a random time, that is a back off. Now stop sending the data, waiting for the random time. Once the time is available, time slot is available, now again it is sending. If the the collisions are free, then only it is sent. Then attempts to resending, then it is attempt to the sending. So CSMA CD, which is helps to reducing the collisions in a busy networks, but now is a less effective in a high traffic other conditions due to the potential for the collisions and delays. Generally, it is used in a Ethernet. Ethernet networking now, it can be utilized. CSMA, CD, other protocols can be utilized. CSMA, CA. CSMA, CA means collision avoidance. So whatever the collisions are detected over the network now, so that detected collisions, that means carrier sense multi-access the collision avoidance, different other mechanisms can be used for avoiding the collisions. So different mechanisms, that means you may use the state-free mechanism or Banker's algorithm or collision avoidance, the technique. Different other techniques can be used. By using that other techniques now, the collisions, wherever the collisions are occurred in a network over the network now, all the collisions can be removed. So networking protocol for the carrier transmissions of the data. If it is the protocol, so that works with a medium access control layer. So if it is when the data frames is sent to the particular channel, it receives an acknowledgement to check whether the channel is clear. If it is the channel is clear now, then only sending the data. If the channel is not clear, stop the sending the transmissions. That means that the station receives only single acknowledgement. That means the data frames has been successfully transmitted to the receiver. Suppose the acknowledgement now, if the sender sending the data to the destination, from that the destination which is receiving the one acknowledgement, single window acknowledgement here, immediately now which is understood as a data transmission successfully sent. But now if it gets the two signals, so it wants and one more in which the collision of a frames two signals along with acknowledgement, so which is detected as collision is occurred. A collision of the frame occurs in a shared channels. That collisions, wherever the collisions are occurred, that the collisions at the shared channels now, it will be removed by applying the different other mechanisms. Banker's algorithm now you can use generally state-free algorithm. So different algorithms now, the collision detections, the avoidance collisions can be avoided. Detecting the collisions of the frames when a sender receives the acknowledgement of the signals. Here is advantages of random access protocol in a medium access control is it is a very simple and decentralized network. So it is very good for the low to moderate traffic loads. The data transmission traffic is a low and moderate. So for that it's a very good random access protocol in medium access control is a very good. Disadvantages of this one now, so not very efficient under heavy traffics. Suppose if the traffic is very heavy, it is not efficient. Why? Because now the collisions will be arised. If the collisions are arised here, you have to retransmitting the data. Again, if it is collisions are arised, again you have to retransmitting the data. That means the effective communication now, we can't establish the effective communication. That's why it is not very efficient under heavy traffics or large networks. Can lead to the delay also. So which is taking the delay data transmission and reduce the throughput in a crowded networks. These are the advantages and disadvantages of the random access protocol in a media access control. And the textbooks for this random access protocol in a medium access control is data communication and a network and computer other networks. So data communication networks is the 4 region and computer networks is the 10 and 1. These two textbooks are good for this topic, and this is about the collisions detections and collision the avoidance. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.